So yesterday, first part of 6.6, we looked at geometric sequences. We extended those sequences, right? We did the next three terms. We talked about common ratio. We graphed it. We saw that it was exponential. So today what we're doing is we are dealing with equations. Okay, so we're taking those geometric sequences. We are going to put them into an equation, and we're going to be able to find the 8th term or 10th term or 20th term or whatever we want. Okay, so what we're looking for, or what we're looking at here in terms of an equation, is going to look very similar to just our exponential. Okay, I'm going to write it down, and then we'll talk about what everything means. And this is our equation for a geometric sequence. All right, so let's talk about the different parts here. Raise your hand and tell me, what do you think one of these things stands for? One of these things, what does it stand for? Tate?
R is like the rate.
R is the rate, sort of, yes. What did we talk about yesterday that might have had an R in it? Levi?
The
Common ratio, which is basically the rate, right? But we want to use the phrasing, common ratio. So it's what we're multiplying by every time, right? That's our common ratio, what we're multiplying by every time. That's R. And that should make sense, right? In our exponential equation, AB to the x power, B was what we were multiplying by every time. Okay, so it's that same idea. Okay, any ideas on the A sub 1 or the N? What we think those might be here? Eli, what do you think?
the A1, would that be the first term?
Yep.
Or the,
Yep, that's the first term. Remember, the A tells us that it's a term, and then the number in the subscript here tells us which term it is. So this is the first term. Okay.
N is the number we're looking for.
Yeah, N is what number term it is. So what number term we're looking for, what number term we're talking about. Okay, and then the A sub N, that's just the nth term. So that's our answer, right? If we're looking for the 7th term, then that's the 7th term. That's our answer. Okay, so if we have a geometric sequence, let's say we're going 4, 12, 36. We don't need many terms here to be able to do this equation. Really, we only need 2 if they tell us for sure it's a geometric sequence. But having 3 kind of reassures us that, yeah, we've got a geometric sequence. So if we just want to create an equation, okay, not knowing what term I want yet, I want you to plug in all the information that we know right now. Without knowing what term we're looking for, just plug in all the information we already know. Okay, double check the person next to you, make sure you've got stuff in the same spot. So this is gonna be the first question most of the time on these problems, is just to create the equation, create the general form of the equation for the geometric sequence. So it's always gonna have the a sub n, and then what's it gonna equal? What do we have on the other side there? Oh,
4 times 3, then parentheses, n minus
so we got 4 times 3 to the n minus 1. And there are different ways you could write it. You could put parentheses around the 3 instead of having that dot there. That's fine. We just got to know that that is 4 times 3 to the n minus 1. I put parentheses around this. The book doesn't. I do it because if you're ever going to type that into a calculator, it's going to need parentheses around it. Okay. Realistically speaking, once we put a number in, you're just in your mind going to subtract 1 and put it there. You're not going to actually type in something minus 1 in the calculator. So that's our answer to the first part of the question. Okay, the first part is always just going to say, write the equation. Then it's going to say, all right, what is the whatever term? Okay. I want you to take this now. I want you to find the 8th term. Find the 8th term. Use your calculator. Find the 8th term. Okay. Regina, what do we get for our 8th term? What do we have for the 8th? Maddie?
8,748.
8748? All right. There you go. Good deal. Remember, you have to subtract 1 from that 8. Okay? The common mistake is just put an 8 there, do 3 to the 8th. You have to do just 3 to the 7th. All right. Good deal. Let's find the 11th term. Starting to get pretty big numbers, right?
Yep.
Geometric, we're multiplying every time, so numbers are going to get really big really fast. Oh, one more. Let's go 15. really big, really fast, right? 15th term, we're looking at 19 million at this point, right? Okay. Any questions on that? Okay. All right, so that's our general idea, right? This is our equation for the geometric sequence. Let's talk about trying to get a real world. Well, let's talk about COVID. Talk about COVID, sickness, right? You can get other people sick. Let's say it starts with 2 people. 2 people come into the country with it. Let's say those 2 people each infect 3 other people, right? Each infect 3 other people. So if 2 have it, they infect 3 other people each. How many total do we have now? 8. 8, because you got to have the original 2 still, right? Okay, so that's after 1 transmission. Right, 2 people coming in the country. Now we got 8 people. Let's say this is before, we were wearing these things and doing all the social distance and everything. What's it going to be after 5 transmissions? I want the 5th term here. I want the 5th term. Now I know we said each person infects 3, but look at what we multiplied by. Right? We multiplied by 4 instead. So that common ratio is actually 4 here. So you got to count the original people. Okay, what was that 5th term? 512. 512, right? Our equation, our original amount is 2. Our common ratio is 4. You still have that n minus 1 that you got to type in there. So you can't do the 5th power, you got to do the 4th power, right? So we got 512. Not bad, right? It's okay, 512 out of a whole country. Not bad. Okay, let's jump. 15th term. Sticks around, people don't know. They have it, they start giving it to other people. 15th term. Well, that's a lot of people, isn't it? Hey, that's 536 million. It's a good thing we're wearing masks and doing this stuff, right? So this doesn't happen. Because at that point, that's more people than we have in the country. Right? Okay. So it jumps real quick, real fast. Exponential grows and grows and grows and grows. Okay? So anytime you hear of something, and they talk about it from time to time, you'll hear it. People say it grew exponentially. And I think people don't necessarily mean what they're saying when they say that sometimes. But if something's growing exponentially, like actually growing exponentially, it is going to get super big, super fast. Right? Not at the beginning. 2, then 8, then 32, then 100 and whatever. Right? It's not that much at the beginning. But once you start getting into those big numbers, and we're timing it by 4 every single time, we do one more, we're at 2.5 billion. And then we're at 10 billion. We're at the whole world, right? It gets really big, really fast. Okay? That's what I want you to understand about exponential, and regardless of virus or whatever. I just want you to understand exponential or geometric sequences are going to get really big, really fast, which is why we don't necessarily ask for the 15th term a whole lot, because we're going to get really big numbers. Okay? Most of the time it's going to be, here are 3 numbers to start. What's the 7th term? Or what's the 8th term? Make it a little more realistic. Okay? All right. Any questions right now about that? Cool. Say it again. A half term? We don't necessarily talk about half terms. I mean, technically you could, right? You could type that into the calculator and get it. But that's not something that we think about. Yeah. Okay. All right. Let's look at something else here. We got a little bit of a word problem. And we could, well, I'll give you a second to read it. Go ahead and read it. Okay, and we could, if we really wanted to, start setting up this equation and try to solve it. The problem with that is going to come in, we don't know how to solve. We don't know how to solve this, where our variable's in the exponent. We don't know how to do that. Okay. The reason we don't know how to do that is that was 6.5, and I told us we weren't doing that. Okay. So when you see this type of problem, we're going to fall back to your favorite thing. And what your normal fallback is, you're going to guess and check. Because you're just going to type it in until you find your answer. And instead of, and it's not necessarily even using the formula, right? You know the pattern. We're multiplying by 2 every time. Multiply by 2 every time until you get to that 640. You just got to pay attention to how many clicks it is. Okay? That's how you're going to do that type of problem. Because we're not going to get into solving for the exponent in the variable, or the variable in the exponent. Okay?
So for that, when we're writing our answer, do we start at 5 and then keep going up?
So this is saying it's 5 after 1 click is what it says, right? So we would, whatever one gives us 640, whatever that number is, that's going to be our answer.
So you would start at 0.
Yes. Yep. Okay. So that's all we're doing on that. Okay. No fancy formula. Just do it how, if you had no other way of knowing, however you would do it, which is just keep multiplying until you get there. Okay. All right. Good deal. Any questions on it right now? Okay. We've got our formula.